which covers a continent about twice the size of Australia, and contains 70% of the world's fresh water, is also beginning to melt. Ice shelves that extend from the continent into the surrounding seas are starting to break up at an alarming pace. In May 2007, a team of scientists from NASA and the University of Colorado reported satellite data showing widespread snowmelt on the interior of the Antarctic ice sheet over an area the size of California. This melting in 2005 was 900 kilometers inland, only about 500 kilometers from the South Pole. Conrad Stephan, one of the scientists involved, observed, Antarctica has shown little to no warming in the recent past with the exception of the Antarctic Peninsula, but now large regions are showing the first signs of the impacts of warming. The ice shelves surrounding Antarctica are formed by the flow of glaciers off the continent into the surrounding sea. This flow of ice, fed by the continuous formation of new ice on land, and culminating in the breakup of the shelves on the outer fringe and the carving of icebergs, is not new. What is new is the pace of this process. When Larsen A, huge ice shelf on the east coast of the Antarctic Peninsula, broke up in 1995, it was a signal that all was not well in the region. Then in 2000, a huge iceberg nearly the size of Connecticut, 11,000 square kilometers, or 4,250 square miles, broke off the Ross Ice Shelf. After Larsen A broke up, it was only a matter of time, given the rise in temperature in the region, before neighboring Larsen B would do the same. So when the northern part of the Larsen B ice shelf collapsed into the sea in March 2002, it was not a total surprise. At about the same time, a huge chunk of ice broke off the Thwaites Glacier, covering 5,500 square kilometers. This iceberg was the size of Rhode Island. Even veteran ice watchers are amazed at how quickly the disintegration is occurring. The speed of it is staggering, said Dr. David Vaughan, a glaciologist at the British Antarctic Survey, which has been monitoring the Larsen ice shelf closely. Along the Antarctic Peninsula, in the vicinity of the Larsen ice shelf, the average temperature has risen 2.5 degrees Celsius over the last 5 decades. When ice shelves already largely in the water break off from the continental ice mass, this does not have much direct effect on sea level per se. But without the ice shelves to impede the flow of glacial ice, typically moving 400 to 900 meters a year, the flow of ice from the continent could accelerate, leading to a thinning of the ice sheet on the edges of the Antarctic continent. If this were to happen, sea level would rise accordingly. The International Institute for Environment and Development, IED, has analyzed the effect of a 10-meter rise in sea level, providing a sense of what the melting of the world's largest ice sheets could mean. The IED study begins by pointing out that 634 million people live along coasts at or below 10 meters above sea level, in what they call the low elevation coastal zone. This massive vulnerable group includes 1/8 of the world's urban population. One of the countries most vulnerable is China, with 144 million potential climate refugees. India and Bangladesh are next, with 63 and 62 million respectively. Vietnam has 43 million vulnerable people, and Indonesia, 42 million. Others in the top 10 include Japan with 30 million, Egypt with 26 million, and the United States with 23 million. The world has never seen such a massive potential displacement of people. Some of the refugees could simply retreat to higher ground within their own country. Others, facing extreme crowding in the interior regions of their homeland, would seek refuge elsewhere. Bangladesh, already one of the world's most densely populated countries, would face a far greater concentration. In effect, 62 million of its people would be forced to move in with the 97 million living on higher ground. Would a more sparsely populated country like the United States be willing to accommodate an influx of rising sea refugees, while it was attempting to relocate 23 million of its own citizens? Not only would some of the world's largest cities, such as Shanghai, Kolkata, London, and New York be partly or entirely inundated, but vast areas of productive farmland would also be lost. The rice-growing river deltas and floodplains of Asia would be covered with salt water, depriving Asia of part of its food supply. This loss of prime farmland would parallel the loss of river water as Himalayan glaciers disappear. In the end, the question is whether governments are strong enough to withstand the political and economic stress of relocating large numbers of people while suffering losses of housing and industrial facilities. The relocation is not only an internal matter, as a large share of the displaced people will want to move to other countries. Can governments withstand these stresses, or will more and more states fail? More destructive storms. Rising seas are not the only threat that comes with elevated global temperatures. Higher surface water temperatures in the tropical oceans mean more energy radiating into the atmosphere to drive tropical storm systems, leading to more destructive storms. The combination of rising seas, more powerful storms, and stronger storm surges can be devastating. Just how devastating this combination can be became evident in late August 2005, when Hurricane Katrina came onshore on the U.S. Gulf Coast near New Orleans. In some Gulf Coast towns, Katrina's powerful 28-foot-high storm surge did not leave a single structure standing. New Orleans survived the initial hit, but was flooded when the inland levees were breached, and water covered everything in large parts of the city, except for the rooftops, where thousands of people were stranded. Even in August 2006, a year after the storm had passed, the most damaged areas of the city remained without water, power, sewage disposal, garbage collection, or telecommunications. With advance warning of the storm and official urging to evacuate coastal areas, 1 million or so evacuees fled northward into Louisiana, or neighboring states of Texas and Arkansas. Of this total, some 290,000 have not yet returned home, and will likely never do so. These storm evacuees are the world's first large wave of climate refugees. Katrina was the most financially destructive hurricane ever to make landfall anywhere. It was one of 8 hurricanes that hit the southeastern United States in 2004 and 2005. As a result of the unprecedented damage, insurance premiums have doubled, tripled, and even in some especially vulnerable situations gone up tenfold. This enormous jump in insurance costs is lowering coastal real estate values and driving people and businesses out of highly exposed states like Florida. The devastation caused by Katrina was not an isolated incident. In the fall of 1998, Hurricane Mitch, one of the most powerful storms ever to come out of the Atlantic, with winds approaching 200 miles per hour, hit the east coast of Central America. As atmospheric conditions stalled the normal northward progression of the storm, some 2 meters of rain were dumped on parts of Honduras and Nicaragua within a few days. The deluge collapsed homes, factories, and schools, leaving them in ruins. It destroyed roads and bridges. 70% of the crops and much of the topsoil in Honduras were washed away, topsoil that had accumulated over long stretches of geological time. Huge mudslides destroyed villages, burying some local populations. The storm left 11,000 dead. Thousands more, buried or washed out to sea, were never found. The basic infrastructure, the roads and bridges in Honduras and Nicaragua, was largely destroyed. President Flores of Honduras summed it up this way: overall, what was destroyed over several days took us 50 years to build. The damage from this storm, exceeding the annual gross domestic product of the two countries, set their economic development back by 20 years. In 2004, Japan experienced a record 10 typhoons, hurricanes, that collectively caused $10 billion worth of losses. During the same season, Florida was hit by 4 of the 10 most costly hurricanes in U.S. history. These 4 hurricanes together generated insurance claims of $22 billion. Against this backdrop, Insurance companies and reinsurance companies are finding it difficult to calculate a safe level of premiums, since the historical record traditionally used to calculate insurance fees is no longer a guide to the future. For example, the number of major flood disasters worldwide has grown over the last several decades, increasing from 6 major floods in the 1950s to 26 in the 1990s. Insurers are convinced that with higher temperatures and more energy-driving storm systems, future losses will be even greater. They are concerned about whether the industry can remain solvent under this onslaught of growing damages. So too is Moody's Investor Service, which has several times downgraded the creditworthiness of some of the world's leading reinsurance companies over the last 6 years. Thomas Loster, a climate expert at Munich Re, a leading reinsurance company, says the overall balance of natural catastrophes is now dominated by weather-related disasters, many of them exceptional and extreme. We need to stop this dangerous experiment humankind is conducting on the Earth's atmosphere. Munich Re has published a list of natural disasters with insured losses of $1 billion or more. The first one came in 1983, when Hurricane Alicia struck the United States, racking up $1.5 billion in insured losses. Of the 58 natural catastrophes with $1 billion or more of insured losses recorded through the end of 2006, 3 were earthquakes, including the devastating 2004 earthquake-related Asian tsunami. The other 55 were weather-related storms, floods, hurricanes, or wildfires. During the 1980s, there were 3 such events. During the 1990s, there were 26. And between 2000 and 2006 alone there were 26. Prior to Hurricane Katrina, the 2 largest events in terms of total damage were Hurricane Andrew in 1992, which took down 60,000 homes, and racked up $30 billion worth of damage, and the flooding of China's Yangtze River Basin in 1998, which also cost an estimated $30 billion, a sum comparable to the value of China's rice harvest. Part of the growing damage toll is due to greater urban and industrial development in coastal areas and river floodplains, but part is due to more destructive storms. In the West, the regions most vulnerable to more powerful storms currently are the Atlantic and Gulf coasts of the United States and the Caribbean countries. In the East, it is East and Southeast Asia, including China, Japan, the Philippines, Taiwan, and Vietnam, that are likely to bear the brunt of the powerful storms crossing the Pacific. In the Bay of Bengal, Bangladesh, and the east coast of India are particularly vulnerable. Western Europe, traditionally experiencing a heavily damaging winter storm perhaps once in a century, had its first winter storm to exceed $1 billion in 1987, one that caused $3.7 billion of destruction, $3.1 billion of which was covered by insurance. Since then, Western Europe has had 9 major winter storms with insured losses ranging from $1.3 billion to $5.9 billion. As the climate changes, more extreme weather events are expected. Andrew Lukalecki, a consultant on climate change and its effects on financial institutions, notes that damage from atmospherically related events has increased by roughly 10% a year. If such an increase were to continue indefinitely, he notes, by 2065 storm damage would exceed the gross world product. The world obviously would face bankruptcy long before then. Few double-digit annual growth trends continue for several decades, but Lukalecki's basic point is that climate change can be destructive, disruptive, and very costly. If we allow the climate to spin out of our control, we risk huge financial costs. In a late 2006 report, former World Bank chief economist Nicholas Stern projected that the long-term costs of climate change could exceed 20% of gross world product, GWP. By comparison, the near-term costs of cutting greenhouse gas emissions to stabilize climate, which Stern estimates at 1% of GWP, would be a bargain.